Hello, Socrates at Saddlebrooke. Stuart Orr here, discussing what does it mean to be human. This is part 3 in our series, and today we're going to discuss consciousness. Do you ever think about what consciousness is? We're all conscious beings. What does that mean? We know what unconsciousness is. That's when we get up in the morning and we don't have our morning coffee yet, right? That's unconsciousness. But consciousness is what gives us our view of reality. It's our window onto the real world. Do you know we actually have 2 windows into reality? Not just one, there's 2 windows. There's an external view that we have, that we see with our eyes, and then there's an internal view of what we see in our mind's eye. Let me explain this with the use of the thinker statue when I was visiting San Francisco's Legion of Honor Museum. And I love the thinker. That's our logo for Socrates. So I was particularly drawn to thinking about that. And I see the statue. I see the thinker up there. And I'm processing through my eyes, which comes back to my brain. And we can actually trace these signals that goes on. That's one view. That's my external view of the world. But simultaneously, I have something going on up here. I'm not only seeing the statue I have an internal view in my mind's inner eye, which is about the statue, about Rodin, about the past. I'm pulling up and comparing it to some history I knew about this in the past. Those are 2 different things, 2 different experiences of reality, physical and mental here. I'm actually viewing reality of the statue through 2 different windows. In my brain, I see it through my eyes, what's out there, and in my inner mind, I see about the statue. I am conscious of the statue's physical reality through my physical senses, but I'm also conscious of the statue's reality in a mental state. How do I bridge that chasm? What happens? What is going on inside of me as a human being to be able to bridge that gap between physical and mental consciousness? Well, in science, this is called the mind-body problem. It's been around since the beginning of time, but it was brought into vogue to discuss it as a philosophy by Descartes. And it raises huge questions. In fact, it separates the sciences from the material sciences. The material sciences say strictly that there's only physical view of reality, and everything else is just an illusion. We have some problems with that in Socrates here, because we don't just take that for granted. We want to explore what this means. We explore the mind-body problem. They are different views, and if they're different, how are they possibly tied together so I have a simultaneous understanding of what I'm looking at? I will propose a hypothesis in the talk that you're about to hear. Then second, I'm going to address an even deeper question than that. If my brain is physical, and it is, there's neural networks in my brain, and we have nerve cells, and we can measure what's going on in this physical activity. That's the body part of the mind-body model. But when the body dies, my eyes obviously don't operate anymore. I don't have any aware of physical consciousness when my brain dies. But this mental reality that I'm talking about, that's immaterial. We don't measure that. We don't put instruments on there and know what the color blue is. We don't know what my thoughts about Rodin are that's going on in my mind. We don't measure that. We have no machines to measure that kind of thing. But it's real. It's the mind part of the mind-body model. It's non-physical. It's non-material, immaterial in that way. So what happens to that when I die? Does that die too? I mean, perhaps we've talked about our conscious state and in some of these past lectures perhaps my mind as an immaterial entity still functions as an immaterial soul, part of my immaterial soul, and it survives death. There's no reason for the immaterial to die a physical death. It's not physical, right? Perhaps there is an afterlife here that most world religions believe right off out of the chute. They believe that. So this is an interesting connection between science and faith. Is death the final frontier? Not necessarily. Right? If we assume it's just physical, yes, that's the final frontier. But we're exploring the other side. And we're also going to investigate today a third major question. The mind-body are two views. How do they get integrated into one view of reality? When I think about Rodin and the statue and so forth, I don't think of two different things. I see in my mind's eye, I see that statue. I see it right up here in my library. I'm thinking about that. But I also remember 10 years ago in San Francisco when I viewed it up there. So we're going to explore a proposed scientific answer to how these two things integrate. And it comes from the new physics of quantum mechanics. Now I call it new, but it goes back 100 years. And it's probably the most tested theory that there is about what real matter at the very fundamental level is. You've probably heard the particle and the wave, and you're gonna hear more about that from me today. This is a newest branch of physics that describes reality at its most fundamental level. Now, quantum mechanics is validated to so many decimal places, but it's so weird because we don't see it. At the level of our size and being, we don't really see the quantum effects, but as you get smaller down toward the size of the atoms, we see smaller effects. And when it gets to particles as small as atoms, that's how reality works. From quantum mechanics, you can be in two different places at one time, called quantum entanglement. In fact, this was so spooky to Albert Einstein, who was a realist in the sense of he wanted to see physical, empirical evidence for things, that he proposed an experiment to disprove quantum mechanics. And instead, with that experiment, he actually discovered quantum entanglement, which I'm going to talk about today. So pay attention to the forum video cast that's coming up. Two different places at one time. An event can happen here, and it can happen there simultaneously, with no communication between them that we know of. There's no radio wave, there's no signal, there's no particle transmission, there's no matter in between. That sounds spooky, but we take gravity for instance, that we don't know how gravity affects. I have effect on the moon right now. The moon has an effect on me. They asked Isaac Newton, what is gravity? He says, I have no idea. He didn't know, but what he did is he came up with the mathematical equations that explained it, and we just take it for granted because the explanation, we see the effect of it. Well, quantum mechanics is sort of like that too, between the local and the non-local effects. So perhaps the brain is operating locally, and the mind, which is immaterial, is operating non-locally. Listen to the explanation today. So this is exactly what happens in quantum mechanics. I'm going to introduce you to this weird quantum mechanics. In fact, it's so weird that I produced a special bonus video that's on the video cast under quantum mechanics, and it could provide an answer to this consciousness question, as well as the existence of the soul. So for those of you who want to dig into it, please view the quantum mechanics tutorial. Now we're going to pick up my talk at the Socrates Forum at the Saddlebrooke Country Club, where I begin asking this question of Richard Dawkins about, or answering him on his view of faith. He doesn't think faith offers any valid explanations, not even to try. Faith can put hypotheses on the table, and which can be scientifically explored, but they're kept up. People like Dawkins, it's superstition. We don't do superstition in science. Well, this is science. This is real science, and I start off the video with giving an answer to Richard. Here we go.
Now, these are talked about as being faith positions, but what I want to talk about, is there any scientific evidence for these faith positions? My friend, I always use Richard Dawkins because I think he's about the best evangelism for the materialistic side of things, and here's his take on faith. Faith is the great cop-out, the great excuse to evade the need to think and evaluate evidence. Faith is belief in spite of, even perhaps because of, the lack of evidence. Well, Richard hasn't been to a Socrates forum. I think I'm going to invite him to the next one. I doubt if he'll take me up on it. One of our, I won't get into that, but he's one of my favorites. So I said, all right, Richard, what do you propose? What's your philosophy of life? What's your worldview? I mean, we can only come to the end of our data at some point, right? And we take that next step of a conclusion. That next step is the faith step, right? Is it a faith, a reasoned step to faith, or is it blind faith? A lot of times, like Richard thinks this is just blind faith. You have faith, it's just blind faith, and boom, no evidence, and he has all the evidence. No, he has faith too to take his next step, and here's where it leads him. This is his worldview, his philosophy of life, and this is what would be taught if you were teaching materialism. He said the universe we observe has precisely the properties we should expect if there is, at the bottom, no design, no purpose, no evil, no good, nothing but blind, pitiless indifference. That just warms my heart, doesn't it? Warm your heart for the philosophy of life? If I had no reason for faith other than not have that kind of worldview, I'd have faith. Now, at the same time, I look for materialists who come out of the closet, so to speak, and admit that they're inconsistent in their worldview. And this is one of my favorites, Dr. David Barash. I followed him for years. He taught evolutionary biology at the University of Washington, and he's an ardent materialist and an ardent atheist. And when he retired, and now he's a emeritus professor, maybe that's why he was able to say what he really thought in this quote. And it's a long quote, but I'm going to read it. So pick out of it differences between what he teaches in the classroom, what he teaches and when he writes his papers, and then what he really believes when he goes home at night and he kisses his children and he tucks them into bed. He says, I suspect that we all, even the most hard-headed materialists, live with an unspoken hypocrisy. Even as we assume determinism in our intellectual pursuits and professional life, we actually experience our subjective lives as though free will reigns supreme. In our heart of hearts, we know that in most ways that really count, and many that don't, we have plenty of free will, and so do those around us. Inconsistent? Yes, indeed. But like the denial of death, it is a useful inconsistency, and perhaps even one that is essential. That's quite a statement. I mean, I have to give him, regardless if you believe where his position is or not, that's quite a statement. I mean, I have to give him credit for being honest about what's going on. He says unspoken hypocrisy. We assume in our professional life materialism. Materialism is matter is all there is. Matter is all that matters. The cosmos, as Carl Sagan would say, is all there is, ever was, ever will be. There's nothing immaterial in the world. And the first lecture on number 6, it talks about that. You might want to look that one up on the video. And he says, but free will reigns supreme in my personal life. I know I have free will. I know I can raise my right hand instead of my left hand. Whoop, what happened? No? Whoop. And so does those around us. We are very inconsistent. Like the denial, I like this one. At the denial of death, it's a useful inconsistency. We deny we have death, don't we? I want you to do something. Look at your name tag. No, not that one. No. The tag that has your expiration date on it. I want you to look at that one. You all have one. We all have one. How often do we look at that name tag and kind of orient our life toward what it says on that name tag? But it's perhaps even an essential one. Well, if you want to keep your job in biology, you better not talk like that. So summarize what we talked about so far is life has a goal, teleology, an intended end which it strives to attain. Staying alive, love that. Staying alive, the Bee Gees. Cells have built-in mechanisms that communicate and self-regulate. Talked about that last time. Every cell maintains internal equilibrium and adjusts to its changing conditions. And when homeostasis is successful, life continues. When it fails, death results. Today we're going to say, is there any scientific evidence for immaterial communication? We know what nature says about the material. What about this immaterial soul that we have, that we call our soul anyway, inside? Is there any scientific evidence for it? Is there any scientific evidence that this communication that the cells all have with one another and how it regulates life, that communication ends at death? Maybe it continues on at death. Is there any scientific evidence for the soul? And that's how I'm going to look at it. And I'm going to discuss the scientific principles of quantum mechanics. How many of you, I know a couple of you are expert in this area, how many of you never heard the term before? I think everybody probably heard it. I mean, even if it's on Star Trek or things pop into existence, and how does that happen? You go to the Discovery Channel and you see claims that are way beyond the evidence. So we're not going to talk about those kind of claims that are way beyond the evidence. We're going to look at what hard evidence we can actually look at and see if they can be explained by quantum mechanics. But look at this quote from the Brainy quote. The development of quantum mechanics early in the 20th century, this has been around for a long time, obliged physicists to change radically the concepts they use to describe the world. And it does. Very counterintuitive. In fact, I'm going to warn you, Niels Bohr is going to warn you. If you think back to your high school science class, or look at the symbol on the atomic energy, you have the nucleus and you have the electrons going this way and electrons going this way. And that was Bohr. Bohr came up with that model and of how that works. And there's some amazing things that go on with quantum mechanics. And it blew his mind. And he says, if quantum mechanics hasn't profoundly shocked you, you haven't understood it yet. So be prepared to be profoundly shocked and try to at least know what they're talking about. And where I'm going with this is quantum mechanics opened up a whole world of understanding of what's called non-local events. Non-local events. What's a non-local event? We know it. Well, a local event is right here. We know what's going on. If I throw this off here, it's going to drop to the floor because of gravity. I can calculate the force that it's going to hit the ground with, how fast it's going. Those are local events. Let's take the billiard table. Isaac Newton used the billiard table. C.S. Lewis used the billiard table. It's a good one. Think about a billiard ball moving. You walk into the pool room and there's the billiard ball moving. Well, that's the effect. What was the cause of that? Well, some cue ball hit that ball. No, we go back, and the cause was the cue ball that hit this ball. Well, what caused the cue ball to hit that ball? Well, the striker. There he is. He's about ready to shoot the cue ball, hit the cue. That's going to hit the ball, and the ball is going to move. And this is normal cause and effect. This is called a local event. But let's look into the world of the subatomic particles. We weren't able to do this until just within the last 50 to 100 years, and perform these kind of experiments. Let's instead of a cue ball, let's have a subatomic particle, and he's going to blast this with this cue ball. And this is what happens at the CERN accelerator. You've heard of cyclotron and so forth. They try to atom smashers. They accelerate particles as fast as they can, get them as close to the speed of light as possible, which is the limit of any speed in the universe, and then shoot it at a particle and see what happens. Well, that's what he's doing. Here's the particle accelerator right there. He's going to blast that, and he's going to blast that particle, and boom, what happens? These two particles go out, these parts of the particle go out, and they keep on traveling. They're going to go out, way out. Let's put them way out to the end of the solar system. Remember, the solar system is the sun and the planets go around and so forth. We go out past Jupiter, we go out past Neptune, so forth, billions of miles across. Well, these particles are going to shoot out to ends of the solar system. And I'm going to introduce you to our two observers here. We have two observers. One, Alice and Bob are our friendly observers. We're going to use them in another experiment as well. This pair of atomic particles is sent off into opposite ends of the solar system, and Alice and Bob are stationed there, and the particles have a property. You know, like we have pluses and minuses on particles. You know, it says if they're two states. Well, these particles have two states too. The property is called spin, and instead of plus and minus, you can think of it as plus and minus, but it's not electromagnetic charge. It's called spin, and it's either up or down. It's either up or down. That's all it is. Spin. But here's the most fascinating thing about this spin phenomenon, is it can only be known when it's observed. Huh? What does that mean? It can only be known when it's observed. All right, well, I'm going to show you what it means. The observer must engage his or her mental capacity to know whether it's up or down. So Alice views her particle, and she discovers what it is, and then we're going to ask what Bob's particle is. There they are. They're a little more romantically involved too. You can tell by the conversation there and the smile on her face and his yes dear response right away, right? You can tell they're romantically involved. Oh, Bob, I looked and my particle spin is up. What's yours, darling? Alice, I don't know. I'll check it out right away and get back to you. Okay, so we're going to get, and here's a picture of what's going on. It's called quantum entanglement. So we have the solar system, we have Alice on one side observing, and we have Bob observing, and Alice looks at it, and it says, my spin is up. So is Bob up or down? I heard up. Do I hear down? Do I hear I don't know? Do I hear 50-50? I mean, that's what classical physics would say, right? I mean, it's 50-50. I mean, I don't know. I mean, they're billions of miles apart. Come on. Well, here's the difference between classical physics and quantum physics. Classical physics, 50-50 chance, right? Okay. Quantum physics says Bob's particle is up, not with 50% certainty, with 100% certainty. 100%. These particles, how are they communicating? In classical physics, the observer is independent. It doesn't make any difference if it's Bob or Alice or whatever. And whether or not what you view, the results are going to be independent of the observer. But in quantum physics, it's observer dependent. Wow, well, that's really strange. How does that work? Well, classical physics might say, well, the particles must be like socks. I mean, if you have a left-hand sock over here, if Alice has a left-hand sock and you know it's a pair of socks, and then Bob has to have a right-hand, so we know what the answer, no, it doesn't. This actually depends on the observer's action. Actually depends on the observer's action. Alice and Bob communicate through a physical connection, billions of miles apart. Bob, Alice, no. Einstein's theory of relativity, which has been proved to, 15 decimal places or something, is there's nothing that will move faster than the speed of light. And the speed of light couldn't possibly get across the solar system in that amount of time. As a matter of fact, it's zero time. Zero time. It's simultaneous. The communication is simultaneous. This really bothered Einstein. Einstein was a strict determinist in many ways, and in this way he said, this is spooky action at a distance. He said, I don't know how it is. He's the one that actually came up with this experiment back in 1935. It's a thought experiment. Why Einstein was such a brilliant theoretician is because he thought about things deeply. He just didn't go along with extending the calculations or coming up with a fancier way of doing it or whatever. He performed thought experiments. And he said, all right, I'll come up with this thought experiment on quantum entanglement, thinking that he's going to prove that this couldn't possibly happen. It's been shown to be true. Experimentally, it's been shown to be true. Experimentally. So I'm talking about real science here. And this bothered him until he died. And the action of a mind playing a vital role as well as being experimentally verified. So what happens with materialism in this kind of case? I mean, it loses its dominant position in physics now. Part of it, I mean, materialism is important, but there's something else going on. Actually, the universe appears to be an integration of mind and matter, which we'll call observation. One of the parallel scientists to Einstein at the time was Sir James Jean. Won't go on with his tremendous credentials, knighted and so forth, National Academy of Sciences, Royal Society. And he put it this way, he said, the stream of knowledge, and this was over 50 years ago, and this has even been way beyond verification at the level at his time. The stream of knowledge is heading toward a non-mechanical universe. Up until this time, it was a mechanical universe. Newton's laws held and so forth, and there had to be connections between things, and there had to be cause and effect that we could see, feel, and touch. Sir James says, the universe begins to look more like a great thought than a great machine. Very interesting comment. Well, how do we know that this stuff is true? Because we have mathematics. Not only experimental evidence, we have mathematics for this whole thing. It's called the quantum wave equation. You ever see that funny little symbol there? See the Greek symbol psi there? That stands for the quantum wave mechanics. And you used to see Einstein, somebody at the board, and all these equations all over the place. Well, that's the equations behind what's going on here. And what it's telling us is we don't know the position of a particle. We don't know the position of the particle exactly until it's observed. So, is it there? Probably. Is it there? Could be. Could be with a little less probability. Could it be over here? Yeah, with even less probability. You know the bell curve, right? This follows a bell curve. Could it be way out here? Yeah. Could it be way out here? Yeah. I remember one of my physics classes, the professor was saying, it's theoretically possible, the air in this room, all the molecules could all of a sudden decide to be over in that corner. And I saw all of us going like this, gasping for breath, right? The last thing we wanted to do is be caught short of air. That's the quantum wave function. You can calculate with precise probability anyway where that particle is going to be. They call it and when we observe it, then all of a sudden we know where it is because this quantum wave function, they say it collapses to a particular value, and that's where it is. So as soon as Alice observed that particle, boom, she knew it was up, it was right there, and Bob better get his act together and give her the right answer, right? Or he's in trouble. How do we explain this interaction? Well, you can understand it a little bit if you know what waves are. And who doesn't know what a wave is? I mean, we all been there in the pool, right? Or in the ocean, I should say, the waves. That's a wave. It has an amplitude, high, has a frequency. That's high frequency. That's low frequency, right? And we know that objects have what appears to be a dual nature. We've known this, we've suspected this for 200 years now, that is light a wave or a particle? You might have even heard that expression before. Is light a wave or a particle? Well, the answer is it has a dual nature. Sometimes it acts like a wave, sometimes it acts like a particle. It depends on what the experiment is at the time. Well, let's take this quantum mechanics into the world of neuroscience, which is really getting even spookier now. All right. We have an immaterial aspect to our minds. At least that's what I believe. A lot of us believe that. A lot of great theoretical physicists believe that too. Can we prove all this stuff? We can't prove it for it or against it, but we can certainly look at evidence, right? We can look at what the science tells us. And quantum neuroscience is looking at what goes on in the mind and with regard to local versus non-local events. Now these positions, like I told you about, there versus there versus there versus there, that's non-local. That means that we don't know for sure exactly. Look at the drop of water coming down. That's a drop of water. I can calculate when it's going to hit the water, how fast it's going, and so forth. But look at what it causes. It causes waves, and these waves not only start, they go out, and they go out forever. They keep on going out, and they have a certain amplitude, and they have a certain frequency, and so forth. And there's events based on the one event that it could be there or it could be there, but that's where the wave equation comes in, and we can calculate it, we can experiment and find out, yep, that's true. Quantum reality, where objects are both particles and waves. So if there's particles, we have matter in motion, material in motion. That's normally talked about in classical physics. But with waves, I'm claiming here that there's immaterial aspects of this whole thing that are in motion at the same time. Dual nature of light goes way back to 1800. Dual nature of particles, electrons, 1927. This has been around a long time. You might have seen some of these experiments, like the double slit experiment, if you've done any reading in this area at all. Sometimes the light goes through and it looks like it's a particle on the experiment we hit, and other times it has wave characteristics. It's waves and particles. Waves spread out in every direction forever. Local events are ruled by classic physics. The rock there, classic physics. What's happening with the wave fronts is ruled by quantum physics. I told you, Niels Bohr told us right from the very beginning that if quantum mechanics hasn't profoundly shocked you, you haven't understood it yet. Here's another claim that we've talked about before, that the mind is not the brain. The mind is not the brain. Materialism says everything happens in neurosciences in the brain. The mind is outside the brain, is what the claim in quantum neuroscience is. Okay, let's first start with the brain here. That's about the size of my brain right there. I know the normal brain weighs about 3 pounds, generates 25 watts of electricity, 100 billion neurons, 100,000 miles of axons, 100,000 thoughts a day, 250 miles an hour speed, processes 100, it goes on and on, a million billion pieces of information. Incredible. Brain waves, yes, we measure them all the time. EEGs. Some of you probably had EEGs before. You find out that the brain waves are 4 types, 4 dominant types. There's the real fast ones like the alpha brain waves, there's a high frequency. When we sleep, it's slow delta brain waves. The information storage of our memories, like we talked about the information storage of going back 25 years and remembering the smell of the pizza. Remember that when we talked about the smell? Oh yeah, I remember I had my first date. I can still smell it in my brain, in my mind. That brain appears to function as a relay station to the brain rather than just be the coterminous with the brain. So this is a new perspective on consciousness. The mind is not the brain. Consciousness is not generated by bodily functions. We can't find a place in the brain that is where consciousness originates. We can't measure what consciousness is. We can measure some of the characteristics of it, but we can't come to any kind of conclusions. The brain is not the cause of consciousness, but rather the effect of consciousness. Consciousness is explained in quantum neuroscience as not a local event in the brain. Consciousness is a non-local event of the mind mediated by quantum mechanics. The mind is capable of changing the brain. Some of you already know that, I'm sure. You can change your behavior. Changing the brain function and structure, even change the DNA. Some fascinating research at UCLA with Jeffrey Schwartz, a neuropsychiatrist. He has tremendous experience in changing obsessive compulsive behavior and changing people's brains by forcing it on the explanation from the mind. And we know we have all kinds of testimony for religious, mystical, and spiritual experiences. And they can be explained, at least the hypothesis side, by non-local events. So does scientific evidence reveal an immaterial mind transcending the material brain? Well, these are called religious, spiritual, or mystical experiences. And I'm going to talk about two of them today. I'm going to talk about a spiritual one, which is a near-death experience. I'm going to talk about a mystical one, which is called Ganfield experiments. And we'll save talking about religious experiences when we talk in part 7 of who is God. So, it's a neuroscience answer to a big question. How about life after death? That sounds like a good one to go after, right? Life after death. I don't know, about 4 times ago we asked, is space the final frontier? We grew up in the Star Wars generation where we were told space was the final frontier. No, the final frontier is given by that expiration date that we wear. Death. We are the only species to try to make any sense out of death. Remember that song, any of you remember Fly Like an Eagle, the Steve Miller Band? Fly like an eagle, time keeps on ticking, ticking, ticking. That used to really bother me. Time keeps on ticking. Yeah, I gotta stop. Smell the roses, time keeps on ticking into the future. That's true. But the good thing about death is what Socrates started telling us. It focuses our attention, doesn't it? Socrates said, philosophy trains us to face death. Steve Jobs gave a remarkable talk in 1995, a commencement speech at Stanford University. This was a decade or more before he died. And he said, death is life's change agent. It's the single best invention of life. My favorite popular philosopher is Woody Allen, right? I'm not afraid to die, I just don't want to be there when it happens. We're going to talk about I picked Pam Reynolds as a near-death case because this one was so monitored, fully monitored and witnessed because it had such notoriety and there's so much objective, independent, verifiable scientific evidence that supports her testimony. So we'll look at Pam Reynolds' case. She was beautiful, as you can see, beautiful singer-songwriter. She had a giant aneurysm in her brain. Would have burst at any time, and that would have been the end of her. And she learned about Dr. Robert Spetzler at the Barrow Institute up in Phoenix. And he's a world-renowned neurosurgeon that he specialized in this hypothermic cardiac arrest, which we'll talk about a little bit. What it is, she basically had to die so he could get into her brain and repair the aneurysm. And she made that decision to die to save her own life. And this has been fully monitored and witnessed and objective, independent evidence. All right, let's talk about the operation, first of all. It was a 7-hour operation. There was 20 surgeons and attendees and nurses at this operation. Cardiac doctor plus doctors plus neurosurgeons plus. They couldn't have any stimulation in her brain. Didn't want any stimulation at all. So they taped her eyes shut. First of all, she's under full anesthetics. Eyes taped shut, big earphones on with click, click, click at a high decibel, almost like a train ride, because they wanted to monitor through EEG what was going on in her brain. She's on full life support for the rest of her body. Cut into her skull, drained the blood from her brain, brought her temperature down to 60 degrees. On the way down, she has an immediate cardiac arrest, so she dies. Literally, she's clinically dead. She's flatlined in every function in the heart and in the brain. There's no activity whatsoever. And when that happens, when there's no more blood in the brain vessels there, the aneurysm collapses, and the surgeon goes in there and does a very simple job, right? Up until this point, it was been very difficult. But he clips that out and repairs it, brings Pam back to life. Okay, so what's going on with her? She's going through what's called an out-of-body experience. You've probably heard about out-of-body experiences and certainly seen cases or heard of cases. There's no heartbeat, no brain waves. She felt herself pop out of her body. This is her testimony right after the operation when she was able to talk. She describes the operation. She talked about her shaved head. She was expecting when she went into it that all her hair would be shaved off. No, it was just a certain portion and a weird haircut, she said, a very weird haircut. She saw them cut open her skull. She thought that they'd have a saw where they'd cut open the skull. No, it was more like a dentist drill. It's a special tool, and she describes this thing in minute detail, what this drill is. It even had a dent in it, which she described. She hears the conversations, because when they drain the blood from her, they have to poke into a major artery and drain the blood, and the nurse, one of the attendants, says her arteries are too small. There's mild panic there, and the heart doctor said, try the other side. So they do that and successfully drain the blood. And then as she's coming back they're bringing her back to life, she's testifying that it felt like plunging into a pool of ice. So what's her mystical experience out of this whole thing? Well, this is pretty common for near-death experiences. Body is floating effortlessly, and they almost always talk about unconditional love. They're fully accepted in this state. In fact, after they come back, any of the people that experience this, never afraid to die, and they always feel this unconditional love. They have encounters with, she had an encounter with her grandmother who's been dead for decades, and her uncle led her back to her body afterwards. She had an experience with him. They usually see a tunnel of light, and she, in her case, in most of the cases, they have a sense of a being of light. Time keeps on ticking, but doesn't tick. I mean, it just kind of suspended, time suspended. And there's a sense with these folks when they come back too, that there was boundaries that they couldn't transgress. I mean, if they went outside the boundary, that was it. But if they stayed within the boundaries, they could return to the body. Dr. Robert Spetzler, he was the world-renowned neurosurgeon that performed this operation, and also emeritus chair of the neurosurgery at University of Arizona. He pioneered this technique of hypothermia and cardiac arrest, and has published. His credentials go on and on and on, hundreds of articles, textbooks. So he validates he validated the facts of this case, that she was anesthetized, instruments were covered, her eyes and ears were totally obstructed, Pam flatlines both heart and brain function, and he says in a BBC movie that was put together, I don't have an explanation for this. I don't know how it's possible. Now you might think, well, this is a religious experience. I mean, people who have a religious and spiritual insight and so forth, those are the only people that have these kind of things. No, here's one of the world's most famous atheists, Sir A.J. Ayer, that's how you say his name, Oxford professor and atheist. He wrote an article in the London Guardian, What I Saw When I Was Dead. He experienced one of these near-death experiences, and quote, I was confronted by a red light, exceedingly bright and also very painful. I was aware that the light was responsible for the government of the universe. That's quite a spiritual experience. He said the experience weakened his logical argument against God, but he hopes there is no afterlife. That's one of my favorite atheist philosophers, Thomas Nagel. He said the same thing. He said, you know what, the evidence is there and so forth. I just hope God doesn't exist. And that's what he thinks. So, near-death experience testifies to the mind transcending the brain. Something has to be going on besides the brain, right? Tens of thousands of documented cases, thousands of studies in the last 50 years in this area. Surveys in the US and Germany suggest that as many as 4.2% of the population has had a NDA, and perhaps 25 million cases. All walks of life, every sort of religious and philosophical conviction changes lives, mostly for the positive. Near-death experience people no longer have a fear of death. Well, maybe NDEs are explainable as a non-local event mediated by quantum mechanics. Maybe. Wouldn't that be fascinating research to be involved in, though? I mean, shouldn't we be funding activity like this where we bring together the immaterialists and the materialists to really study these things? Schrödinger, Erwin Schrödinger, Nobel laureate, he's the guy that formulated the psi equation. He says, consciousness cannot be accounted for in physical terms. For consciousness is absolutely fundamental. It cannot be accounted for in terms of anything else. I believe that. One more I'm going to give you, and then we'll open it up for your comments and discussion, questions, whatever. Answers to big questions from quantum neuroscience. Is there telepathic communication during life? We talked about afterlife. How about during life? We all think, oh yeah, I have a sixth sense, and the longer you're married, you know what the person's thinking and so forth. Well, is there any scientific evidence that bears this out? I'm going to tell you about the Ganzfeld field experiment. There's thousands of different kinds of experiments I could have picked. I picked this particular one because you'll relate to it, to Alice and Bob again. I'm going to get Alice and Bob can be our observers here. Now, these general areas of experiments are called PSI. It's a general term for any telepathic or paranormal phenomenon. And since the 70s, for the last 50 years, there's been experiments, a lot of experiments between two minds, where subjects are placed in two different rooms, and one will be the transmitter and one will be the receiver. Ganzfeld is German, right? Ganzfeld. Ganzfeld means whole field. And how it started off was they wanted to see if they could help people by depriving them of all their physical senses. And they would do this by putting them, obstructing their sight, their sound, putting them in a state with like a red light area, and just to deprive them from the physical aspects of sensory perception, because they could even achieve maybe an alternate state of consciousness, because the mind will operate on, it'll always try to make sense out of something, but if you've deprived them of any physical sensory perception, then the mind will focus on whatever it can get, whatever small information it can get. And that was the whole idea of using this experiment. Let's block out the world from folks and see if we can pick up even a weak signal. So the picture package experiment was just Alice and Bob. I'll introduce you to Alice and Bob again. So Alice is the sender, and she's given a random package of pictures. And Alice selects a package by random, she selects a picture by random, and tries to telepathically send it to Bob. Bob's in another room, no connection. Everything is done to separate and make this as foolproof as possible. He's the receiver, and then he attempts to choose the picture that Alice selected. So she's given 4 pictures, and out of those 4 pictures, she picks one. So Bob is trying to pick the picture that she picked, and his hit rate should be what? Yeah, 1 out of 4, right? I mean, at random. So he's going to get it right 25% of the time. But hundreds of independent lab studies around the world show Bob's hit rate consistently above 30%. Now, that's not a huge difference. It is huge if you do this 200 times in a row. If you do this 200 times, in fact, a lot of times, here's a picture of Alice there trying to transmit through telepathy to Bob, and his choice is much greater than 25%. In fact, it's common to hit 32%. For doing this repetitively and looking at all of the metadata behind it and everything, the chance rate of doing this at 32% is 1 out of 10 to the, forget it. Forget it. So we have 2 sides interpreting this. Skeptics and materialists have an interpretation on one side, and people who believe that something like this is possible on the other side have another interpretation. So skeptics would respond in several different ways. Well, there's poor experimental design. I mean, that's the first. You have to have good, if you're going to do good science, you better have the best experimental design that you possibly can, because the whole idea of science is to be able to reproduce a result, reproduce it, and another person to reproduce it, not just you doing the reproducing, and it's not just subjective, it's somebody else's objective evaluation of it. So we need good experimental design. Well, it's a trivial effect, small effect, just happens. Or there's an explanation, but it's an unknown material explanation. Certainly the quantum entanglement, we don't have a material explanation because we can't even get a signal across the universe. Here we can get a signal across the room, maybe something that we don't understand we're going to discover. Denial is another one. I don't want to pay attention to that, and they don't. And declare it to be pseudoscience. So my favorite scientific journal is Wikipedia. You know that, right? I can trust Wikipedia all the time. Things of this nature that aren't materialistically explained are always just called pseudoscience, whether there's any explanation. You would think, at least, if this is trying to be a balanced position, that they'd say, well, here's what this group's evidence is, and that's what we try to do here. Let's get the evidence on both sides. And I'll allow any of you to comment or say something to the contrary on this. But declaring it to be pseudoscience or just writing it off doesn't really help advance the search for truth, does it? A number of top theoretical physicists, however, believe that non-local mind can mediate this through quantum physics, and quantum physics plays a role. And I'm going to end with, at 5 o'clock here, I'm going to end, before we open it up, with Sir Roger Penrose. You might know Penrose from Penrose and Hawking and discoverer of the black holes, and he's probably one of the greatest theorists on quantum gravity there is, and he says, where he stands on this is consciousness is part of our universe. So any physical theory which makes no proper place for it falls short of providing a genuine description of the world. And I agree with that. Let's go for the genuine descriptions. Let's look at the evidence. Let's weigh it for ourselves and decide for ourselves. Does it point this way or does it flow that way? Thank you, Sir Roger.
Now, Classical biology has no mechanism for explaining mind-body consciousness other than saying that it emerges as a result of brain evolution. You hear that and you go, oh, okay, they know. They don't know. That's just an assertion. There's not a mechanism. That's not a scientific mechanism of cause and effect. That's an assertion. They assume because time goes over time, things evolve and get maybe more complicated. That eventually it'll get so complicated that voila, the consciousness just happens. No explanation of this. You dig into the neuroscience on this, no explanation of it. They're looking for the mind consciousness as for an organ in the brain or electrical signal. No explanation. I mean, obviously they're tied together. Mind and brain are tied together, and that's what they report on. But that's the brain functioning. So emergence is just an assertion. It's not a mechanism. Emergence to provide the genuine description of consciousness that Roger Penrose asked for is not there. But under the sway of the philosophy of materialism, biology gives us just Darwinian assertions. Darwinism ignores and rejects evidence from the new scientific hypotheses that don't fit their materialistic model. Now, there's been a lot of things proposed from quantum mechanics, from neuroscience, from intelligent design, kept off the table. We don't allow that kind of thing, is what the materialistic science says. But at the same time, old school Darwinism is in charge. And it's been so ingrained into the scientific process and the biologist's mindset for 150 years, because that's all we teach in school, that Darwinism defends its territory without having to offer a genuine description, because they are in control. All right, today, these new sciences, however, open up many avenues of exciting research in biology. It can't be ignored. If I was starting my career all over again, I might even want to be a biologist. I mean, that wasn't my field. My field was in physics. But these things are really exciting. They can't be ignored any longer. So the good news is that science keeps on growing and changing. And 100 years ago it was one thing. 100 years from now it's going to be something else. But it progresses steadily. Let's just hope that the good news, that the data, the people that are doing these explorations, the data will win out, and it will win out eventually. And you, as a fellow Socrates, a Socrates student, we're made to think, right? I mean, that's why we're part of the Socrates team here. We investigate the data for yourself. Weigh it. What's the evidence say? If the evidence does it point that way, or does it point that way? Follow the path wherever it leads. Don't just say, I'm not going to go down that path. Don't go down that path if it's superstition, but if it's real science and there's empirical evidence enough to make it a hypothesis, investigate it. Decide which way it points. Now, next time, we're going to take another small question like we did today. Another small question. What is the meaning and purpose of life? Have you thought about that one? That's going to be an exciting topic. That'll be part 4. But until then, I keep on reminding you to keep thinking deeply about life and about reality. Follow the data, follow the evidential trail, and wherever it leads you.